Hello everyone, welcome to Biotech Easy. I'm Saloni Dibe, former research associate Medgenome. This video is for students who want to clear their basic concepts in electricity. So this is the first video regarding electricity. Have you ever wondered when you switch on a torch or connect a bulb to a cell, why the bulb lights up? The answer is electricity or current. Today I will explain what is current, what is an electric cell, how it is lighting up the bulb, what is a cathode and anode. All of you must have seen a cell. We use it in torch, TV, remotes, clocks, etc. It has negative terminal and a positive terminal. At negative terminal, electrons are present and they always want to reach the positive terminal. As you can see in the figure also, from the negative terminal, electrons are coming out and they are coming to the positive, they are traveling through the circuit and coming to the positive terminal. Here you can see a symbol I, which is also traveling from positive terminal to negative terminal. I will explain what it is, but first you should know that one electron carries charge, and this charge is equivalent to 1.6 multiplied by 10 to the power minus 19 coulomb. So when electrons are flowing, they are carrying the charge through the circuit. So we can say what is electricity and current. We can say that flow of electrons which carry charge generates current or electricity. So electricity is generated when electrons flows through a circuit. Flow of electrons is from negative to positive terminal and this is called electronic current. But conventionally, flow of positive charge is from positive terminal to negative terminal and this is called conventional current. So whenever we are drawing any circuit diagram, in that diagram we always show the direction of current from positive to negative terminal, and this is also called the conventional current. So in a circuit diagram we always shows conventional current direction, which is from positive terminal to negative terminal. There are two more important terms to understand. First is cathode, another is anode. In general way, both can be positive or negative depending on the accumulation of charge and presence or absence of an external cell or battery. So this is the main topic that will be cleared today. So this is a typical appearance of a dry cell, which we use in TV, remotes, torch, or our wall clocks. So before directly annotating this cell as positive and negative, let us understand the chemistry of reactions happening inside the cell when when the two ends are connected with a wire. So a dry cell has brass capping, pitch seal, zinc container, cardboard cover, sodium chloride, zinc chloride paste, MnO2 paste, and carbon. And in the middle, it has a graphite rod, and at the base, it has a brass plate. When two ends of the cell are connected with a wire, zinc from zinc container, it loses electrons and get oxidized. So you have to understand this. Whenever any atom loses electron, it gets oxidized. So zinc is getting converted, this zinc electrode solid. Here the atoms are getting oxidized and they are forming zinc ion and they are releasing two electrons, and all these electrons are getting accumulated at the brass plate. So that's why this brass plate is termed as negative terminal, because all the negative charge of electrode, electrons has negative charge 1.6 multiplied by 10 to the power minus 19 coulomb. So all these electrons which are getting generated, they are getting collected at the brass plate, and electrons are negatively charged, so they always want to travel towards the positive charge. And how they will travel? They will travel through this wire. So these the arrows in orange indicates the direction of the flow of electrons. So these electrons travel from the brass plate to the circuit to reach the opposite end, the carbon rod. So at the carbon, and yeah, since there is buildup of negative charge due to loss of electron at the bottom of the cell near the brass plate, it is negative terminal. and electrode which gets oxidized means loses electrons is the anode. Here it is zinc. So you can remember anode as an ox. Here A for anode and O for oxidation. So anode is what, where oxidation happens. Other than this, in zinc chloride solution, in zinc chloride paste and ammonium chloride paste, there are ammonium ions and chloride ions. These ammonium ions migrate towards the graphite where electrons are coming, and they gain electrons, means they get reduced. In this process, ammonia gas is evolved, and this again goes to ZnCl2 to form a complex. So we can say that cathode is where electrode gets reduced, means gains electrons. Here it is the graphite rod, because all the electrons are coming towards the graphite rod, and there these ammonium ions are coming and they are getting reduced. Let us see in detail. In ammonium chloride solution, the ions are present, ammonium and chloride ions. Ammonium ion come to the graphite tube and they get reduced to ammonia, and in this process 2H positive ions are also released. This H positive ions, they react with 2MnO2 to form Mn2O3 H2 and 2 units of positive charge. This positive charge is transferred to the carbon rod and it becomes the positive terminal. That's why in a cell that we use in torch or battery, one terminal is the positive terminal, the other terminal is the negative terminal. The positive terminal is the cathode, because their electrons are coming and they are getting consumed. At the negative terminal, electrons are getting accumulated and they want to travel to the positive terminal. So anode is negative and cathode is positive in a general dry cell. In the beginning, I have told you about cathode and anode can be positive or negative depending on the presence and absence of an external source or cell and reactions taking place. Here I will discuss this. So this is a galvanic cell. It does not has an external cell or battery, means here we will not use any dry cell or battery. Here only two electrodes are there. One is zinc electrode, another is copper electrode, and they are suspended in their respective salt solution. Zinc electrode is suspended in zinc sulfate solution, and copper is electrode is suspended in copper sulfate solution. In this aqueous electrolytic solution, zinc and sulfate and copper and sulfate exist in ionic form. Zinc exists in Zn2 positive, sulfate exists in SO4 2 negative, copper exists in Cu2 positive form. In a general way, zinc has more tendency of losing electrons when compared to copper. So zinc loses electrons, means it gets oxidized to Zn2 positive, and whatever electrons are released, copper accepts it and it gets reduced to solid copper. So copper has a strong pull for electrons. So whenever these two electrodes are connected with a wire, copper pulls the electron generated by zinc electrode. Zinc gets oxidized and the zinc atom in the solid electrode after oxidation gets converted to Zn2 positive and comes into the solution. So with time the zinc electrode will get reduced. So all the electrons which are being generated, they will travel from zinc to copper, and from the zinc electrode, the zinc will get dissolved in the electrolytic solution. It will come in the electrolytic solution in the form of Zn2 positive ion. And at the cathode, whatever electrons are coming, this Cu2 positive ion which is present in the electrolyte, it will come and it will get reduced and it will get deposited on the copper electrode. So here what is happening, here there is reduction of copper ions. So at this copper electrode, reduction is happening. So if you remember the mnemonics, red cat, R for reduction, C for cat. So it means cathode is where reduction happens. So here it is the copper electrode where reduction is happening. So copper is the cathode and anode is the zinc electrode. But here anode is positive. Why? Because after releasing the electrons are not getting accumulated, they are being released, they travel through the wire and they come to the copper electrode. But here there is buildup of zinc positive ions. So due to the buildup of more positive ions, this anode is given or annotated as positive. Here at the copper electrode, which is our cathode, because reduction of copper ions is happening, negative charge is getting accumulated due to reduction of copper ions and increase of sulfate ion. Negative charge is getting accumulated. So here cathode is negative. This is our electrolytic cell. Electrolytic cell converts electrical energy into chemical energy, and it requires external voltage or battery source to make the electrons flow from one electrode to another. External voltage or battery source means they require a battery, which is the combination of cell, or they require external dry cell. So I have already explained that external dry cell have predefined positive and negative terminal, and why one terminal is positive, why another terminal is negative, that also I have explained. So here the electrodes are connected with the positive and negative terminal of the given dry cell or battery. In this diagram, two electrodes of copper are present. Well, these electrodes can be different also. One can be copper, one can be zinc. But I have used, for your understanding, I have used the same electrodes. And the electrolytic solution is copper sulfate. In aqueous solution of copper sulfate, copper exists as copper ions and sulfate exists as sulfate ions. When electrodes are connected with a wire and cell of one copper wire and cell, one copper electrode has higher potential. The one connected with the positive terminal, it will have the higher potential, while the other will have lower potential, the one connected with the negative terminal. Sulfate ion get attracted towards the copper electrode connected to the positive terminal of the cell, because sulfate is negative, so it will get attracted towards the electrode which is connected to the positive terminal. It reacts with the electrode to form copper sulfate. In this way, this electrode will get thin with time, and in the process this copper will release or lose electrons. Again I'm repeating, it will lose electron. Lose electron means it is getting oxidized, so it will lose electrons, and these electrons will now flow or will get attracted towards the positive terminal. They flow through the negative terminal and they will come to the other copper electrode which is connected to the negative terminal of the battery. At the negative terminal copper electrode, here electrons are coming, and these electrons will reduce the copper ions which are present in the electrolytic solution. So here what is happening? Here reduction is happening. So this electrode, which is where reduction is happening, that will be cathode. Red cat, R for reduction, C for cathode. And since this cathode is attached with the negative terminal of the battery, here it will be negative. The other electrode where oxidation is happening means it is losing electrons, that will be anode. An ox, A for anode, O for oxidation. And since this is connected to positive terminal, here anode will be positive. So reaction in aqueous solution is what? Copper sulfate aqueous solution, it is dissociating into ions, Cu2 positive, then sulfate ions. Copper ions goes to the cathode copper electrode and accept the electron. Its charge get neutralized and it get deposited on copper cathode electrode. Now reaction on cathode is copper is accepting the two electrons and it is getting reduced to copper, solid copper. It get deposited on the cathode. Reaction around anode, what is happening? Sulfate is coming, it is reacting with the anode, which is the copper, and copper releases two electrons and it combines with sulfate to form copper sulfate and goes into the aqueous solution, making the electrode thin and thin with time. So in summary, what we can say about cathode and anode is, at cathode reduction happens, means gain of electron happens. At anode oxidation happens, means loss of electron happen. There is one mnemonics to remember it: red cat, R for reduction, C for cathode, and ox, A for anode, O for oxidation. Now in galvanic cell, where no external source of battery or cell was there, only the two electrodes were connected with a wire, their cathode is positive, as electrons get consumed at cathode. So in galvanic cell, electrons gets consumed at cathode because something will be there which will get reduced. So cathode is positive. In galvanic cell, anode is negative, as electrons are getting generated and accumulated at anode. So here anode is negative. Now in electrolytic cell, where external source of battery or cell is there, what will be the polarity? Here cathode is negative, as it is connected to the negative terminal of the cell or battery, and all the electrons from anode means where oxidation is happening, where electrons are getting released. So all the electrons from anode, they will travel through the positive terminal, then negative terminal, to get consumed at the cathode electrode. So that's why in electrolytic cell, cathode is negative. Now what about anode? Anode is connected to the positive terminal of the external battery or cell. Electrons generated at anode are pulled up by the positive terminal of the battery to flow through the circuit. So here anode is positive. In electrolytic cell, anode is positive. So students, I hope your confusion regarding cathode and anode is clear, and your confusion regarding that how for one cell cathode can be positive and how for the other cathode can be negative. If you have any doubt, you can anytime rewind my video to get your doubt clarified again and again. So this is the summary of the video. Thank you students. Be an explorer and a learning, and wait for my second video, electricity part 2. If you like this video, if your doubts get clear, then please like this video, please subscribe to my channel, and all the best.